In this video, I'm going to talk about transformation of trigonometric expression. Now, this is from the topic of trigonometry, and you will be given expression in trig form, and then you will be asked to express in this form: r cos theta plus or minus alpha, or you have to transform in terms of r sine theta plus or minus alpha. So this is the thing that will be given. This is known as the trigonometric expression, and you will be asked to transform in this form. Right now, some steps that we are going to use here is basically we will be finding the value of r, because in this expression here we need r, and theta will be found using the technique that we have used in solving trigonometric equations. Right, so let's do an example, and let's transform one trigonometric expression in terms of r cos theta plus or minus alpha, or r sine theta plus or minus alpha. Right, so let's do an example. Example 1, we have expressed 2 cos theta plus 3 sine theta in terms of r cos theta plus alpha. Right, so the condition here is fitting this one. We are dealing with cos, right? We are given in terms of a cos theta plus b sine theta, and we have to express in r cos theta plus alpha. Right, so we have to express in terms of r cos theta plus alpha. Right, so let's do this now. The information that we are provided here is, we know the value of a, right? So the value of a here is equal to 2, and the value of b here is 3. Right, a is coming from here, b is coming from here. Now you can find the value of r. So value of r will be basically, r is equal to the square root of 2 squared plus 3 squared. Right, so this will be the square root of 4 plus 9, and that will be equal to root of 13. So that means our value of r is equal to root of 13. Right, so we have found the value of r. Now let's find the value of alpha. Right, so we have to find the value of alpha. We have found the value of r, and this theta is going to remain here. Right, we don't have to find this, we just have to find alpha, and r we have already found. Right, okay, so now let's find the value of alpha. Now that will take a lot of steps, so we have to write this again. Right, r cos theta, so let's write r cos theta, and plus alpha. So we have r cos theta plus alpha. Okay, now we have to use the addition formula here. Right, we will be applying the addition formula. The addition formula says, if we have r cos a plus b, then this is same as r cos of a cos of b minus r sine of a and sine of b. Right, now notice here that cos theta plus alpha is same as cos a plus b. Right, this can be written as cos a plus b. Right, so that is why we have written this formula. we have r cos theta plus alpha. This is same as a plus b, and this is coming from the addition formula. This is from your formula sheet, right? Now our value of a is basically theta, right? A is theta and b is alpha. So we can write here that our a is theta and b is alpha, right? We have to note that. Okay, so let's replace that in this equation here. So this will become r cos theta, because a is theta, plus alpha, right? And that is same as r cos of, now a is theta, cos theta, cos b is alpha, minus r sin a, in place of a will write theta, and sin b is same as alpha, right? Okay, now we can substitute r. Let's say substitute r. Okay, now when we substitute r, in the place of r we are going to write the value of r, which is root 13. So let's do that. That will be root of 13 cos theta cos alpha minus root 13 sin theta sin alpha, right? So we have substituted r. That is what we mean by substitute r. So root 13 cos theta cos alpha, root 13 sin theta sin alpha, right? Now what we are going to do, we are going to compare the sine and the cosine function, right? So we will be comparing this function with all of this, right? So that will be our next step. So we have to compare the sine and the cosine function. So I'll write here compare sine and cosine function, right? So compare sine and cosine function. Now your original function was 2 cos theta plus 3 sin theta. So you have 2 cos theta plus 3 sin theta, right? And whatever you have from here is root 13 cos theta cos alpha. So you have root 13 cos theta cos alpha minus root 13 sin theta sin alpha, right? Now when we say compare sine and cosine function, what we actually mean is we have to look for cos here and look for cos theta in this, right? So from here we have 2 cos theta. So let's compare that. Let's make a partition here, and let's start with the cos function, right? So if we have 2 cos theta, let's write here 2 cos theta. Now we have to look for cos theta in this expression. We have cos theta here, so all of this is going to come down here, all of this, right? So we'll have root 13 cos theta and cos alpha, right? And this side we have 3 sine theta, and that will be equal to all of this because sine theta is here, right? So all of this is going to come here. That is why we say compare. We are comparing. We had cos theta here, that's why we have taken this root 13 cos theta cos alpha, and then 3 sine theta we have written here, and then sine theta is here in this expression. So we'll take all of this now, right? So the sine will also come, negative root 13 sine theta and sine alpha, right? Okay, so from here we can cancel out things. We can see cos theta and cos theta are common here, so we can cancel these two, right? We are left with 2 is equal to root 13 cos alpha, and this side we can cancel the sine and the sine theta. That is why we are comparing. That is our main goal, is to compare, right? And then so that we can cancel out cos from here and sine from here, right? So sine and sine cancels here. We are left with 3 is equal to negative root 13 sine of alpha. And in the earlier on I have said that we will be finding the value of alpha, right? So you can see the theta cancels out here and here as well, right? So we will be finding this alpha. So notice we have alpha at 2 places, one with the cos function and one with the sine function, right? So let's check where exactly our alpha falls, right? Where exactly. Now this is the most crucial step, and many a times students make mistake here, right? Okay, now when you arrive here, you can okay, you can write alpha. You can say cos, we can divide by root 13 both sides, divide by root 13, and then you can cancel this. You will be having cos alpha is equal to 2 over root 13, and this side if I divide by negative root of 13, negative root 13, I'll cancel this. So the value of sine alpha will be basically negative 3 over root of 13. Okay, now we can see cos alpha here, sine alpha here. Cos having a positive value, whereas sine of alpha is having a negative value, right? Now we are going to use the quadrant method again here, and then we are going to compare which alpha value to take, right? So we have this and this. Let's do it on the other page. Okay, so you have cos alpha is equal to 2 over root 13, and this side you have sine alpha is equal to negative 3 over root 13. Okay, now let's draw the quadrant, right? If you see alpha, let's draw the quadrant here, and let's draw the quadrant here as well, right? So you have 4 quadrants, right? Now cos is positive, so all sine, tangent, cosine, right? Let me write with the pen. So all sine, tangent, cosine, here as well all sine, tangent, cosine. Now cos can only be positive. Look, cos is positive here, right? 2 over root 13. So cos is positive. Now cos can be positive in this region and in this region, right? Cos cannot be positive here and here because sine and tangent is positive here. We have a cos of positive, so we will have this and this, right? So those are the two possible thetas that we can get, right? Okay, look this side. We have sine negative 3 over root 13, right? Now negative cannot be here because everything is positive here, and sine is also positive here, so these two regions are out because everything should be positive here. We have all, and sine is positive here, so this is the two possible regions where sine can be negative because we have a negative sign here. So there and there. Okay, so this is the most crucial place. Okay, and we have to see in which quadrant we have the common line, right? We can call these lines, right? Let's call this line, this another line, this is one line, this is another line, right? So in which quadrant we have common? This quadrant? No, we do not have any here. This one we don't have anything here. Here we have in this quadrant, but here we do not have, right? In this quadrant both doesn't have. First quadrant, the first one has, the second one do not have, right? Well, look at the fourth quadrant. In fourth quadrant we have a line here, right? Both the lines fall in this, so this is the place where our theta will lie, right? So let's put a point here, right? Let's put a point here, and we have to arrive to this point from this direction, right? Now the possible ways we can arrive there is this is one direction, right? Same for this one, we can arrive here at like this, or what we can say, we can arrive at that point in this direction, right? There and there. So two ways we can arrive at this point, one from this direction, right, and another one from this direction, right? Now we are going to find using the calculator, right? We are going to find the value of alpha in both, right? So if I find the value of alpha here, this will be basically cos inverse of 2 over root of 30, and if I do that, this comes to 56.31 degrees, right? Okay, now this side, if I find the value of alpha is equal to sine inverse of, now I'm not going to take the negative sign here, right? We have to ignore the sign. We know that from the solving trigonometric equation, we have to ignore the sign to find the acute angle. So we will say positive 3 over root 13, right? Now when you are finding the value of alpha, you are getting answer as 56.31 here as well, right? Okay, now you have to choose whether to take this as a positive angle or a negative angle, right? And that will be decided from here, right? Now 56.31 degrees, right? 56.31, can you come from this direction? No, we cannot, right? The only way we can arrive to this point here in a 56.31 degrees angle is from the negative x-axis, right? So this means this angle is negative 31 degrees, right? Because this is the only possible way we can arrive at this point, right? And if we take positive, we cannot arrive here because this is 90, this is 90, 180, this is 270, and then it is more, right? It's common sense. So the only way we can arrive here at this point is in a negative 56.31 degree angle, right? So the value of alpha that we are going to take is negative 56.31 degrees, right? So this is our value of alpha. Okay, now it is the time to write your answer. So R cos theta plus or minus alpha. This is found to be negative 56.31. Now we have to express our answer. So your expression was 2 cos theta plus 3 sin theta, and you have to express in form of r cos theta plus alpha, right? So your answer here is 2 cos theta plus 3 sin theta in the form of r. So the value of r you found was root of 13, and the value of alpha that we found was negative 56.3 degrees, right? So that is what we're going to write here. So r, which is root of 13, cos theta minus 56.31 degrees, right? So that is your final answer, right? Let me write this here. So that was root of 13 cos of theta minus 56.31 degrees. So this is a clear version. So all of this and an arrow. So this is your final answer.